Hello, this is Clark Chandler, and I'm here to do a video on basically sort of the concerns that we have to have when we use one-sided methods. And we're going to be using the Excel spreadsheet that we discussed in the last video for this. If you look at the screen, there are it shows you the different transfer pricing methods. And two of these methods, the cup and the profit split, are in blue. And these two methods recorded in blue are basically two-sided methods that take into account the interests of both parties. The cup through negotiation, the profit split because we're looking at the profits of both parties. The remaining methods listed here are one-sided methods, which look at just the interest of one party to the transaction. The RPM and the TNMM with a buyer as the tested party are one-sided methods that focus on the intercompany buyer. The CPLM and the TNMM with the seller as the tested party are one-sided methods which focus on the seller as the single entity that we're looking at. And the basic concern that we have when we use one-sided methods is that because we're just focused on one of the two parties to the transaction, we may come up with prices and recommendations and profits that seem very reasonable for that one particular party, but which may very well lead to unreasonable results for the other party to the transaction. And to explore this, we're going to go up with to the data on the controlled party. We'll leave the data for the uncontrolled party alone, and then we're going to change some of the variables for the controlled party and then try to get back to the starting point operating margins or gross margins of that party. Let's show how we're going to do this. Okay, we've now shifted to our controlled party data where we have the default assumptions about sort of units sold, transfer price, etc., default income statements, and the pie chart showing the allocation of profit. Now suppose we are going to try to target the manufacturer as the tested party, and we are going to take try to use a TNMM to get the operating margin that we're correct. And in this case, the operating margin is 9.1%, and it's the same as for the uncontrolled comparable. But suppose we do something like go up here, and we're going to change the value of the cost of goods sold from that to increasing it to 110,000. As a result of this, the operating profits of the tested party have now fallen from 9.1 to 2.1%. If we want to push these operating margins back up to get it to the 9.1% that is realized by the uncontrolled comparable, we're going to have to do something like increase the transfer price per unit. And if we increase the transfer price per unit to 148, we get a little ways there. To 153, get a little farther there, and to 158, a little bit farther. And so somewhere between 158 and 163, we get a price which brings us basically back to where the comparable is. However, once we've done this, we've had a major shift in the distribution or allocation of profits in the controlled party. The manufacturer is now capturing essentially more than 100% of profits, and the distributor is basically incurring a loss of 3,000. It's incurring this loss because the impact of the increase in the transfer price has been shifted from the manufacturer to the distributor, and that increase has been large enough to put the distributor at a loss. And so when we're thinking about the selection of methods, does the use of this one-sided method, which puts more than 100% of profits with the manufacturer and puts losses in the distributor, make sense? It may or may not. It may very well make sense, but we have to think about how we're going to talk to the tax authorities about this, and we have to think about whether the distributor is willing to incur a loss for a year, 2 years, 3 years, whatever. Now let's reset our default values. So we're going to go back to a transfer price of 143, and we're going to change the cost of goods sold so that it goes back down to the initial number. And here we're now going to say, what if we look at the distributor as the tested party? And once again, we note the comparable had an operating margin of 6.5%. It's the same as our tested distributor as long as the data are exactly the same. But suppose we change the end price per unit and we push the end price down to, I'm going to go all the way down to 170. And what's going to happen here? Well, the first thing, if we were to leave that as is, it puts the distributor at a loss. But because we're treating the distributor as the tested party, were to try to change the transfer price to give the distributor the same 6% operating margin that it had before. And this obviously involves lowering the transfer price, and we lower it. We're up to 4.1%. We're now up to 7%, so somewhere, let's go back to the 4.1%. And so this is the transfer price that would sort of equalize things. So once again, we're focused primarily on the distributor, and so this is the price that and this probably doesn't look too bad. But suppose the end price falls even further and down to 160. Then we have to push the transfer price down further and further, and pretty soon we have the manufacturer operating at loss. And we have the same sort of issues that we talked about before when we're increasing the cost of the manufacturer. Okay, we will now reset all the values and focus and look at what happens when we change volume. And I'm actually going to have a big change in volume and push the volume down to 500. And a couple interesting things occur here. First of all, there's no overall system loss, and that loss is concentrated entirely in the manufacturer. There's no impact on the distributor. So once again, if we want the manufacturer to be the tested party and to earn the same 9% operating margin that we had before, we have to push up the transfer price. We run into an interesting problem. Say that we increase the transfer price all the way up to 185. So we now have it at the same price that the distributor is getting when it sells its product to the end customer. Well, the distributor is incurring huge losses, obviously. The manufacturer is still incurring losses. But more importantly, it is clear that the distributor will not pay 185 for a product that's going to be able to sell for 185. It has no possibility of getting a margin. And to make this even clearer, we could say maybe we put the transfer price up to 190. The distributor now would be losing $5 for every unit that it bought and sold, and so it simply makes no economic sense. So here we have a clear case where using this one-sided method leads to a price that simply cannot exist. Suppose we were to shift to a two-sided method such as a profit split. As you recall, the profit split basically tried to equalize things about 50-50. So can we equalize the losses to about 50-50? Well, let's put the price down again, down again, down again, and we're getting somewhere between transfer price around 170. We're somehow apportioning the loss, sort of still a little bit disproportionate to the manufacturer, but we're getting it somewhat even, more equalized. So clearly the use of a two-sided method of profit split acknowledges the fact there's a system loss and then basically shares the loss between the two enterprises. And so when we're thinking about a one-sided method versus a two-sided profit split method, we have to think about, does it make sense to have all the risks in one entity, or should it be shared between the two entities? Let's reset the prices again. So we'll push the transfer price down to 143, and the end sales price is at 185. One of the things that's interesting here is that all of the loss due to the reduction in volume has been with the manufacturer. The distributor was left unchanged. And so there's an interesting question as to why this has occurred. I'm going to change the frame size a bit so we can see the formula for cost of goods sold. And if we go up to this formula, we see it is 50,000 plus 0.35 times B3 times B4, or units sold times price. So we have a fixed cost component, this 50,000, and then a variable cost which depends upon the number of units produced and the price they're sold at. So the manufacturer faces both fixed and variable costs. If we go down to the distributor, its cost of goods sold are equal to price times quantity, or transfer price times quantity, so that's all variable. If we go down to its operating expenses, and I click here and go up to the formula bar, they also are all variable because it's basically 30% or 30 times the number of units sold. If we were to change this to be a mix of fixed plus variable, so maybe 15,000 plus, and then instead of 30, we go to 15 and turn here, we now see that the distributor's profits have fallen. And basically that's because we've introduced a fixed cost component to things. And so as you're working with the spreadsheet and trying to use it to help solve problems, it's often important to go behind sort of the assumptions that are used in creating the cost base and so forth, and to see how those costs behave. Thank you very much.